Hey everybody, you made it! Last video of the chapter, and at the time of this recording, last video of the year? What? Section 9.82, Partial Fractions, Day 2. It's been a pleasure being with you on this road. Thank you so much for being part of this class, for all your hard work, and let's just end it off with kind of a shortish video. We talked a lot about yesterday, and we're going to capitalize on that, so there's just one more additional question I want to ask, and that is, what do you do if the degree of the numerator is greater than the degree of the denominator? So here the degree is 3 in the numerator and the degree is 2 here. It's cubic up top, it's quadratic down below. That just looks different and involves one more additional step. Let me show you exactly what we're going to do, kind of with just numbers first. It's kind of like saying, hey, decompose 23 over 6. And you can see that this is kind of like a mixed number. Sorry, it's an improper fraction, and the strategy is going to be to change it into a mixed number by dividing. You all remember that if you want to change this into a mixed number, you can ask yourself, how many times does 6 go into 23? It goes in 3 times. 3 times 6 is 18. 23 minus 18 is 5, and so this remainder goes in the numerator, and what you divided by, the divisor, goes into the denominator. 23/6 is equal to 3 5/6. So it's actually a lot easier to decompose 3 5/6 because now we have a fraction that is no longer improper. Yesterday we talked about lots of techniques on how to decompose 5/6, and you can and so that would be 3 plus 1/2 plus 1/3 instead of 3 plus 5/6. That's what decomposition would look like with a improper fraction. So the equivalent in algebra is here, degree higher in the numerator than the lower. And of course, we're going to use division to accomplish this. Polynomial division. Notice that we've got the numerator here, 6x cubed plus 5x squared minus 7, here inside the division house right here. Notice also that there's a linear term that's missing. It goes from 5x squared. There's no, it doesn't say 4x, it doesn't say 2x, it just goes straight down to negative 7. So we need a placeholder for 0x here, and then we're going to divide. You have to ask yourself, how many times does 3x squared go into 6x cubed? Or 3x squared times what gives you 6x cubed? And you can see that the answer is 2x. 2x times 3x squared is 6x cubed. 2x times negative 2x is going to be negative 4x. 2x times negative 1 is going to be negative 2x here. And we do want to subtract. Just like we subtract up here, subtraction is the same. But with all the pluses and minuses and negatives and all that stuff, it's just easier to change all the symbols and add. So we're going to change all the symbols and keep track of with all the symbols by circling them. 6x cubed plus negative 6x cubed is 0. 5x squared plus 4x squared is 9x squared. 0x plus 2x is 2x. Negative 7, and then we just bring down the negative 7. We repeat the whole process again. You ask yourself, 3x squared times what is 9x squared? And that's 3. 3 times 3x squared is 9x squared. 3 times negative 2x is negative 6. 3 times negative 1 is negative 3. And so we're going to change all the symbols and add. Changing all the symbols here, we get that, and when we add, we get this. 2x plus 6x is 8x. Negative 7 plus 3 is negative 4. And this is going to be our remainder. Notice we've got a linear term, we've got a constant term, and then we've got a remainder term, because there's nothing lower than that. So we take our entire remainder, 8x minus 4, and that's the numerator, and then the entire divisor, and that's the denominator here, 3x squared minus 2x minus 1. So this is actually part of the answer, 2x plus 3. You can see over here, fast forward to the answer, you see we can just write that as the answer. The only thing that really remains is to decompose this fraction right here. We have to factor out the denominator, and factoring the denominator, I would use bottoms up. You can use whatever method you want. You get 3x squared minus 2x minus 1 is equal to 3x plus 1 and x minus 1. Those are going to be the new denominators here. 3x plus 1 and x minus 1. And then you run into all the techniques that we did yesterday. You're going to get common denominators. You're going to solve systems of equations. You're going to reinterpret those solutions in terms of the original. You can eventually find that A is equal to 5, B is equal to 1. Yesterday's video was long enough. I don't feel like doing a whole other long video here today. In fact, I don't even really care about doing very much other than dropping right now an audio check. We've got, in 1994, the Academy Award winner for Best Picture was Schindler's List. No study of World War II is complete without watching Schindler's List. Amazing, amazing work done by the lead actor Liam Neeson, and of course the maybe one of the all-time greatest directors of all time, Steven Spielberg. So music by John Williams, I'll also add. They're all just really good stuff. It's great stuff going on. Go and watch it and learn. So there it is. We've got A is equal to 5, B is equal to 1. And so we can reinterpret those solutions to the system of equations here. And that's what you get as our answer. That's the new thing. What I'm trying to say is do everything we did yesterday, and if you see a numerator greater than denominator, then the first thing you got to do is divide using polynomial division. I don't feel the need to do another example. Why don't you just go ahead and start 9H2 by copying the problem list, do the first problem, and I'll see you around.